Identify the greatest common factor, which is the GCF, of the expression 2x squared plus 4x. So in class, we talked about defining the GCF, defining the greatest common factor of polynomials using two questions. The first question is, what is the largest number that divides into all coefficients evenly? And the second question, what is the common letter with the lowest exponent? So before we begin asking ourselves the first question, look at the numerical coefficients of both terms. In this case, we have 2 and a 4. Can the smaller number be divided into the larger number evenly? And in this case, of course, the 2 does divide into 4 evenly. If you can answer this question and the answer is yes, then the GCF of the numerical coefficients is the smaller number. And we don't need to use the prime factorization of both of those numerical coefficients in this case, because both will also show us that 2 is the GCF. So 2 does divide into 4 evenly, so of course 2 would be the answer to the GCF for the numerical coefficients. And when comparing the x to the second and the x here, which is technically the x to the first, they both have x, and x to the first has that lowest exponent, so we use the x as part of the GCF. So here's our answer. The GCF for the expression is 2x. For the next question, 5x squared plus 30x, we're being asked to factor the expression. So we're finding the GCF and then we're going to factor using that GCF. So let's start with our finding the greatest common factor for polynomial questions. But before we go with the prime factorization of both numbers in order to find the GCF, we want to ask ourselves, well, can that smaller number be divided into the larger number evenly? Yes. 5 does divide into 30 evenly. So the answer to the first question is simply 5. 5 is the GCF for 5 and 30. Comparing the x squared and the x to the first has that lowest exponent, so our GCF is 5x. Now, that's just 1/2 of the answer because we're factoring using the GCF. Now, factoring means that we actually think of the reverse of the multiplication that we'd be using typically to solve a question like this. And you can think of the distributive property in reverse. 5x times what term will equal to 5x squared, and that's an x. 5x times what term here will equal to a positive 30x, and that's a positive 6. So we can factor this way. However, if that's not working for you, then just remember that factoring a number out is the same as dividing that number away from the two terms. So we can set up the polynomial right here and divide both terms by a GCF, which is 5x, and that will give us the answers that we need in the parentheses. 5x to the second divided by 5x is x, plus 30x divided by 5x is a positive 6. So we get the same answer. 5x times x plus 6 are the factors of 5x squared plus 30x. Now, you try the next question for number 8. Pause the video, then replay, and you will see the answer. So our answer is 5y squared times 2y minus 1. Well, we have 10 and 5, which are our numerical coefficients. We answer the question, can the smaller number be divided into the larger evenly? And the answer is yes. 5 divides into 10 evenly, so we're using that 5 in our GCF. We have a y to the third and a y squared, and of course the y squared has the lower exponent, so we're using that as a part of the GCF. After factoring out the 5y squared, we end up with 2y minus 1. So this is our final answer, 5y squared times 2y minus 1. The next question, factor the expression 7z to the third plus 56z squared minus 49z. We want to begin the factoring process by finding the GCF. We have 7, 56, and a 49. So can the smaller number be divided into larger evenly? We have 7 that definitely divides into 56 evenly, and 7 also divides into 49 evenly. So we can stop there. We know that 7 is a part of our GCF. Comparing our letters, our variables, and their exponents, z to the third, z squared, and z, we'll be using z. So now we can begin the factoring process. And again, if you can do the reverse distributive property here to factor, do that. If you need to set up the division of our GCF from your polynomial, each term, then do it this way, like so, in order to get what's in the parentheses. So 7z times z squared will equal to 7z to the third. 7z times a positive 8z will give us the 56z squared divided by 7z. And 7z times a negative 7 will give us the negative 49z. Or the division also gives us those same 3 terms. And we have our final answer. Pause the video and answer question number 10. Play the video in order to see the final answer. When asked to factor 77x minus 539x squared, the answer is 77x times 1 minus 7x. First, the 77 does divide into 539 evenly, so that's why we use 77 for the GCF, and we have an x and an x squared, and we use the x. For the next question, this one's a bit different than the previous questions, and it's only different because we have a variable term here, x to the 6, or an exponential expression, that appears not to have a numerical coefficient, but since this is just an x to the 6, you don't see a numerical number here in front of the x, we know that that's an assumed 1. So when finding the greatest common factor of the numerical coefficients, 1, 7, and 6, we know, of course, that 1 divides into both 7 and 6 and itself evenly. So we can use 1 as our GCF. We have the common letters here, all x. The one with the lowest exponent is the x to the first. And that's what we use in order to factor out of our trinomial. So we'll be left with 1x to the fourth times x squared minus 7x minus 6 for the answer. So pause the video and you try number 12, replay the video to see the answer. So the answer is 4x squared times x to the third plus 2x squared minus 3x plus 2. So the next concepts that we're getting into involve factoring by grouping, using the factoring by grouping method. But before we look at a polynomial where we begin the grouping method, let's look at what it means to group factors. So we have x times x plus 1 minus 3 times x plus 1. In order to write the answer for this, first we identify the fact that both groups have an x plus 1. That is what we call common binomial. They have common binomials. So we're going to bring down one of the common binomials. So we'll bring down the x plus 1. And we're going to put the coefficients of those binomials, the x here and the minus 3, in its own binomial. So the answer is x plus 1 times x minus 3. So in order to factor the 4-term polynomial by grouping, first we split the polynomial into 2 groups. We have an x to the third plus 8x squared and a positive 7x plus 56. We're going to find the GCF and factor the GCF for both groups separately. For the first group, the greatest common factor is x squared, or we can say 1x squared. And then that gives us an x plus 8. For the second group, 7x plus 56, the GCF is simply a 7 because, of course, both terms do not have a common letter or common variable. So we factor out the 7, and that gives us x plus 8. So when multiplying, just to check, multiplying our two groups, that will give us the original polynomial. Now we write the answer as an expression using one of the common binomials, so that's the x plus 8. And then we create the second binomial, using the coefficients of those two. So we have an x squared here, and we have a positive 7. We know that this answer is correct because when we use multiplication to multiply these two binomials, it should give us the 4 terms that we started with. So let's check. X times x squared is x to the third. X times 7 is positive 7x. 8 times x squared is 8x squared. And 8 times 7 is a positive 56. So it definitely checks out with the original polynomial. So let's look at the next one here. We're factoring by grouping, so we have the first group of terms, 17y to the third plus y squared. The second, 17y plus 1. So for the first group, the GCF is simply y squared, or we can say 1y squared. And that factors 17y plus 1. The second group, the only common factor that we have for 17 and 1 is just a positive 1. Positive 1. So factoring out a 1, of course, just leaves us with 17y plus 1. So we write our final answer using the common binomial 17y plus 1 times the coefficients y squared and the positive 1. And we want to spend that additional 20 seconds or so checking our answer by multiplying. So 17y times y squared is 17y to the third. 17y times 1 is a positive 17y. 1 times y squared is y squared, and 1 times 1 is 1. And that checks out with the original 4 terms. So now you try number 16. Pause the video and then replay to see the answer. And your answer should be z minus 5 times 6z squared plus 7. For this next 4-term polynomial, there's a slight difference in how the terms look versus the previous examples. And here's the difference. With the second group of terms, we have the negative 35r minus 25. We have a leading negative first term that we will be factoring. Whenever the leading term of a polynomial or group of polynomials has a negative first term, then that means that the GCF must be negative. And we'll see that when we factor out this group. So for the first group, we have 4935, where 7 is the largest number that divides into both, and then we're using the r squared. So 7r squared is the GCF, and when we factor out 7r squared, that leaves us with 7r plus 5. So 35 and 25. 5 is the GCF. However, the leading term is negative 35r. So that means that our GCF will not be just 5, but it will be negative 5. And when we factor out negative 5, that leaves us with 7r plus 5. So our answer includes the common binomial, 7r plus 5, and then our second binomial includes the 7r squared and the minus 5. So for the next one, let's check to see if this answer is correct. Right? We see that the answer is 4x squared minus 7 times x plus 2. But let's just do a quick check to see if the answer checks out. So let's multiply 4x squared times x. That's 4x to the third. 4x squared times 2, which is a positive 8x squared. negative 7 times x is a negative 7x, and a negative 7 times 2 is a negative 14. And the answer simply checks out, right? So just to start, to go backwards, we already know the answer is correct. The GCF for the first group is 4x squared, and factoring out that 4x squared leaves x plus 2. And since we have this negative first term, right? Negative first term for this negative 7x minus 14, the GCF isn't just simply 7, it's a negative 7. And factoring out negative 7 gives us the x plus 2 in parentheses. So our answer is x plus 2, which is the common binomial, and then the other binomial is the 4x squared minus 7. So you see how the order of my binomials are opposite of what you see here? That's fine because it's multiplication, right? I can write it as an x plus 2 times 4x minus 7 or 4x minus 7 times x plus 2. That order doesn't matter. What matters, of course, is what's inside the parentheses and that the signs and terms are correct. A box is constructed by cutting out square corners of a rectangle piece of cardboard and folding up the sides. If the cutout corners have sides with a length x, then the volume of the box is given by the polynomial 4x to the third minus 40x squared plus 100x. So if a box is constructed by cutting the corners, and as you can see in this illustration, cutting the corners of a rectangular piece of cardboard, and we label the sides of these corners as x, the volume of the box is given by this polynomial. So the first question you're asked is to find the volume of the box when x is equal to 4. And that simply means evaluate the polynomial where x is 4. So we plug in the 4 for the x's. And of course, using the correct order of operations, we must find 4 to the third first and then multiply times 4. So we have 64 multiplied times 4 here. We have 4 squared first, which is 16, and we multiply that times 40. And then 4 times 100 is 400. And that gives us 256 minus 640 plus 100, which is 16 inches cubed. And then we're asked to factor out the greatest common factor for this expression. So the GCF is 4x. So looking at 4, 40, and 100, 4 does divide into all three evenly. And x has the lowest exponent. So 4x is the GCF. And when we factor out 4x, we're left with the x squared minus 10x plus 25 in parentheses. And so this gives us the final answer. So a box is constructed by cutting out the square corners of a rectangular piece of cardboard and then folding up the sides. If the cut out corners have sides the length of x, then the volume of the box is given by the polynomial 2x to the third minus 30x squared plus 108x. So to find the volume of the box when x equals to 3, we simply take 3 and replace it with the x in the polynomial, like so. And then we're going to use, of course, the basics of the order of operations. We have 2 times 3 to the third. 3 to the third is 27 minus 30 times 3 squared. And of course, 3 squared is 9. And then plus 108 times 3, which is 324. So we have 2 times 27, which is 54, minus 270 plus 324, and that equals 108 inches cubed. And next we're asked to completely factor the polynomial 2x to the third minus 30x squared plus 108x. So 2x is the GCF of the polynomial, and when we factor out 2x, that leaves x squared minus 15x plus 54. So we're being asked to find the integer pair that has the given product in sum. So the product of 75, and what we'll do is make a table here, and I can list numbers 1 through 12 over here, like so. And take your calculator, divide each of these numbers into 75 and place the answer here. So of course, 75 divided by 1 is 75. 75 divided by 2, that does not divide evenly, so there's nothing to use. 75 divided by 3, and we put 25 here. 75 divided by 4 doesn't divide evenly, so we skip that. 75 divided by 5 is 15. 6 does not divide evenly, 7 does not, 8 does not, 9 does not, and 10 doesn't, 11 doesn't, 12 doesn't. We'll find that once we get back down to 14, we'll be going back to the factors that we already have, which would be 15 times 5. And so we don't want to repeat any of those factorizations. So we have only the 1 times 75, 3 times 25, 5 times 15, and those are all the factorizations of 75. And so we're looking for which factorization adds to equal to 28. That's what they mean by the sum is 28. And of course, 3 and 25 are the factors that add to equal to 28. For the next question, find the integer pair that has the given product in sum. So for this product, we have a negative 22. And when we create our table here, and I'm not going to use 1 through 12 for this one, this 22 is just not going to take much effort. 1 times 22, and of course 2 times 11. That's all that we have. And so since this is a negative 22, one of these numbers must be negative. So it could be a negative 1 times 22, or it could be positive 1 times a negative 22. It could be a negative 2 times 11, or a positive 2 times a negative 11. Either way, we are looking for which factorization will add, right, sum, add to equal to a negative 9. And of course, that would be the 2 and the negative 11. That equals to negative 9. So next we'll be factoring regular trinomials. And by regular trinomials, I'm talking about, of course, a 3-term polynomial where the leading coefficient is simply a 1. In other words, when you look at that trinomial, you do not see a number in front of your variable square. So we will categorize these as regular trinomials. So the first thing that we do with a regular trinomial is we look at the constant term, which is our c here. So consider this our x squared plus bx plus c, and our c is a positive 16. And we want to list all the factorizations of that number. So 1 times 16, 2 times 8, and 4 times 4. Those are all the possible combinations. And we need to determine what factorization adds to give us our b. And our b is the middle coefficient. In this case, that's a positive 10. So we want to know which of these will add to give us 10. And of course, that's the 2 and the 8. Once we have those two numbers, we simply create our binomials using our variable squared, in this case y, is a y and a y, and we use the +2 in one of the binomials and the +8 in the other binomial. And that gives us our final answer, y + 2 times y + 8. So regular trinomials have little effort with respect to factoring. We're simply looking at our c and all the factorizations of c, but we're looking to see which factors of c add to give us b. Once we have the two numbers, we can quickly write the answer. But we also want to take an additional 20 or 30 seconds to check the answer to make sure that our answer multiplies to give us that original trinomial. So here I'll multiply y times y is y squared, y times 8 is 8y, 2 times y is a positive 2y, and 2 times 8 is a positive 16. After combining like terms, I have y squared plus 10y plus 16. And that checks out with the original. So for number 28, you try it. Pause the video, factor this regular trinomial, and then play the video to see the answer. Given that 26 is our C, we will list 1 times 26 and 2 times 13. Those are the only factorizations of 26. And we're trying to find which factorization adds to give us our B, which is 15, positive 15. And of course, 2 plus 13 does. So we write the answer as x plus 2 times x plus 13. So next, we are factoring trinomials in the form of ax squared plus bx plus c, which means that we have a numerical coefficient of our variable squared. And so in class, we talked about the math trick, which really is a shortcut method titled the double AA method. So I'll illustrate that method in this video since your MyLab and my previous videos in Blackboard cover the AC method, which is a version of the grouping method. So I'm going to go through the double A method in this video. So with the double A method, the first thing that we're going to do is multiply A times C. In this case, that's 3 times -8, which gives us a -24. And we're going to list the factorizations of that -24. So we have 1 times 24, 2 times 12, 3 times 4, actually 3 times 4, 3 times 8, and 4 times 6. Since our B is a positive 10, right, it's a positive 10, then that means when we're looking at the factorizations of a -24, the larger numbers, the larger factors over in this column will hold the sign of our B. That means all of these numbers will be positive where the smaller numbers are negative, right? Because we're looking for which of the factorizations will add to give us 10. And so the only possible combination is the -2 and the positive 12 that will add to give us 10. So now that we have those two numbers that we're going to use, here's how we begin the double A math trick. The first thing that we want to do is we want to bring down 3x into the first terms in both binomials. And that's where the actual name of the method comes from, the double A. So we have our x squared here, but we're going to use the A and the A here. 3x and a 3x here, right? That's a little math trick about all of this. Then we're going to place the -2 and the positive 12 in our binomial. So I'll put a -2 there, positive 12 there. It doesn't matter if you put the -2 in the second one and the positive 12 in the first one. That doesn't matter. And the next step is, in order to simplify these binomials, I must divide by the GCF. So the GCF of 3 and 2 is simply a 1. The GCF of 3 and 2 is 1. When I divide by 1, then of course I'm just left with that same binomial. Nothing changes. The GCF of 3 and 12 is 3. It's the GCF. The GCF of 3 and 12 is 3. When I divide by 3, that leaves me with x plus 4. And that is the answer. But before we move on, we must always take our answer when we're factoring, and we want to multiply to check it out to see if it gives us that original trinomial. So we have 3x times x is 3x squared. 3x times 4 is 12x. Negative 2 times x is a negative 2x, and negative 2 times 4 is a negative 8. 3x squared plus 10x minus 8, and that checks out with the original trinomial. So let's do another one using that double A math trick. So again, just verifying that we're factoring a trinomial in the form of ax squared plus bx plus c, because we have a numerical leading term here, and we're using the double A method. So we want to start with our a times c, so that's 3 times the negative 6, which is a negative 18. And that's 1 times 18, or 2 times 9, or 3 times 6. Those are the only possible factorizations. Since, and again, this is a negative 18, so we know that one factor must be negative and one must be positive. But here's how we can determine which will be negative and positive. Our b is a negative 7. So that means that the larger factors will be negative, and those smaller factors are going to be positive. So now we can determine which factorization will add to give us negative 7. And of course, that's the 2 and the 9. 2 and the negative 9, right? Now let's begin that double A method. So we have 3b squared, so we're going to use double A. That means 3b, we're using that twice, right? Double. 3b, 3b. And we're going to place the positive 2 in our binomial and the negative 9 in our binomial. Now we need to find the GCF of 3 and 2, which is just 1, right? 1 is the largest number that divides into 3 and 2 evenly. So dividing that by 1, we're just left with 3b plus 2. Easy enough. The next binomial, we need to find the GCF of 3 and 9. Well, that would be a 3. And when we factor out 3, or divide each of these terms by 3, we're left with b minus 3. So this is the answer, but on the side, we want to check our answer by multiplying. So we're going to multiply 3b times b, which is 3b squared. 3b times a negative 3 is a negative 9b. 2 times b is a positive 2b. And 2 times a negative 3 is a negative 6. After combining like terms, we have 3b squared minus 7b minus 6. And that checks out with that original trinomial. So pause the video and you try numbers 31 and 32. 31, the answer is 3y plus 1 times 2y plus 5. And for 32, the answer is 2v minus 1 times 3v minus 2. For the next trinomial, we must do some things a little bit differently. Since the 12, 8, and 4 are divisible by 4, meaning 4 is the GCF, we must start our factoring using the GCF first. So we're going to divide 4 from the trinomial, which leaves us with 3x squared minus 2x minus 1. Once we've done that, then we can go back to the double A method, or of course the AC method, but again, I'm using our video demonstrations to use double A since it's not in your textbooks and it's not in your MyLab view and example. And let's start the double A method here, but again, you have to keep in mind there was an initial GCF that will be a part of our answer. So we have our A times C, which is a negative 3. And so, of course, only 1 times 3 gives us 3. And in this case, since we're looking for what will add to equal a -2, that's our b here, -2, then the 3 must be negative. So we're using a +1 and a -3. So we begin to set up our double A's. We have 3x squared, so that's 3x, 3x. We're using a +1 and a -3 in our binomials. The GCF for 3x and 1 is just simply a 1, so the 3x plus 1 doesn't change. The GCF for 3 and 3 in the second binomial is 3. So we can factor out, divide out the 3 here, which leaves us with x minus 1. So we have the binomials for this trinomial, but we also have the 4 that we factored out. All 3 factors are a part of the answer. 4 times the 3x plus 1 times x minus 1. For this next trinomial, let's rewrite this trinomial in descending order. So we're going to write the positive 10r squared first, then the negative 29r, and then the positive 10. And from here we can begin using that double A method. So we have 10 times 10, which is 100. That's our A times C. And all the factorizations of 100. We are looking for what will add to give us -29. And the only way to have a positive 100 and a negative middle term, middle coefficient B here, is for both factors to be negative. And so the only factorization that will add to give us a -29, of course, is a -4 and a -25. So we can begin the double A setup. We have 10r squared, so we need a double A. We need a 10r and a 10r. We have a -4 that we're using here, and we have a -25 that we're using. So we need to find the GCF of each of these binomials separately. So 10 and 4, the greatest common factor is 2. So that leaves us with 5r minus 2. For 10 and 25, the greatest common factor is 5. And then that leaves us with 2r minus 5. So our final answer is 5r squared times 2r. 5r minus 2 times 2r minus 5. And then for the next one, we have 14 times the -3 for our A times C, which is a -42. You can list all of those factorizations. Like so. And we're looking for which factorization will add to give us our B, and that's a positive 19. So since we're looking for a positive 19, that means the larger numbers will remain positive, but since this is a -42, the smaller numbers over here will be negative. And the only combination that will add to give us a positive 19 is the -2 and the positive 21. So let's set up the double A method. We have our 14b squared, so we need a double A. We need 14b and 14b. And then we'll use a -2 and our positive 21. And we need to find the GCFs here. So 14 and 2 have a GCF 2. 14 and 21 have a GCF of 7. So that changes the binomials to 7b minus 1 times 2b plus 3.